Okay, so I've got a question here to demonstrate the F equals ma, inertia, and Newton's second law. Let's look at how we solve these questions. A cyclist on a bike with a combined mass of 100 kilograms accelerates from rest with an acceleration of 0.2 meters per second squared. Find the force that the cyclist generates. So I always like to start out by drawing a diagram. In general, I just represent them with a block. Any mass, I just represent it with a block. The mass is 100 kilograms. Put that down there. So they say that they accelerate from rest with an acceleration of 0.2. What does it mean to accelerate? That means that when they start out, this object starts out at rest, it's not moving. So when it starts out, its initial velocity is 0. So we have a letter for initial velocity, u. Our u is equal to 0. And then they tell us that the acceleration is 0.2. Okay, and they're asking for the force that the cyclist generates. So we've said before, force is equal to mass times acceleration. So we're looking for the force. So the force will be equal to, what's the mass of the cyclist? 100 kilograms times their acceleration. They said it's 0.2. So times 0.2. There we go. So what's 100 times 0.2? That's just 20. So the force is 20. And force is measured in newtons, so we'll say 20 newtons. The next question asks, a second cyclist on a bike with a combined mass of 80 kilograms accelerates from rest by generating the same force as the first cyclist. Find her acceleration. So this time we've got another cyclist, just a box, but this time they've got a mass of 80 kilograms. And they're telling us they start out at rest. So u is equal to 0. What else do we know? They generate the same force as the first cyclist. So what's the force that the first cyclist has? 20 newtons. So this other cyclist is also going to be pushed forward by a 20 newton force. There we go. And we need to find the acceleration. So we're going to be like force is equal to mass times acceleration. So this time we know the force. 20 is equal to 80 times a. If we divide through by 80, a will be equal to 0.25 meters per second squared. And this makes sense. The second cyclist has a lower mass and a higher acceleration. The first cyclist is 100 kilograms and has a lower acceleration. The same force acting on two different masses, the smaller mass will have the greater acceleration. Next, we'll try the last question on this paper. Let's just get some space. The first cyclist is traveling at 20 meters per second when he starts to brake with a force of 500 newtons. Okay, now we have to think about this carefully. The first cyclist is traveling at 20 meters per second. So the first cyclist weighed 100 kilograms. And he's traveling at 20 meters. So at the current moment, his initial speed is 20 meters per second right now. So find the distance. So we're looking for displacement that he covers before coming to rest. What does it mean to come to rest? It means that your final velocity is going to be 0. So we're going to involve Suvart equations. SUVAT. So they say that she's braking with a force of 500 newtons. So we can find the acceleration actually, and then we can find the displacement thereafter. So what's the acceleration here? They tell us that he's braking with a 500 newton force. So say he was initially going in that direction. If you start braking, most likely your force is going to be going in the opposite direction because you want to get slowed down. Yeah, you want that force to slow you down. I think you can see that arrow, it's pointing in the opposite direction to where the person might be moving. If they're moving there, the braking force is going in the opposite direction. So let's calculate and see. So it'll be like 500 F is equal to mass times acceleration. So 500 is equal to 100 times A. So our A is actually 5. So our A is 5. But why would this be wrong? This would be wrong partly because they said that they are braking. So this force is trying to slow them down. So their acceleration is not going to actually be 5. It's going to actually be minus 5. Because it's going to be 5 but in the backwards direction. So it's going in the backwards direction. So we can actually see that there's going to be a negative 5. They're going to be slowing down so they can come to rest. It also makes sense because if you're not slowing down, basically you'll never come to rest. If you're in a car and you're just speeding up over and over, if your speed keeps going higher and higher and higher, and you are already moving, you cannot end up at a lower speed than the one you started out with. So let's pick an equation to use. We have UVA and we're looking for S. So I'm going to ignore the T, and that equation will be V squared is equal to U squared plus 2AS. So V squared is 0, that's the final speed that we are looking for, is equal to the initial speed 20, that's our current speed, plus 2 times negative 5 times S. So this will be 0 is equal to 400 minus 10s, or 10s equals 400. The displacement is 40 and the units are meters, so they're going to take 40 meters to come to rest, and that's how you do a question using F equals ma.